This video will include the rest of the connective tissue. Cartilage is a supportive connective tissue that has a flexible rubbery matrix. You can think about places in your body that you know you have cartilage: your ear, tip of your nose, and your larynx. We'll see cells called chondroblasts. They produce the cell matrix, and they surround themselves until they become trapped in these little, it looks like little bubbles, but they're little cavities called the lacuna. And then we'll also see chondrocytes that are the cartilage cells in the lacuna. Now, here your labeling in the lab is going to be very important, that you can tell the difference between the chondrocyte and the lacuna. And then we'll also see perichondrium, which is the dense, irregular connective tissue that surrounds the cartilage, hyaline and elastic cartilage. Well, there's 3 different types, and we'll talk about each one. All the cartilage types do not have blood vessels going through them. They are avascular, and so it is diffusion that brings nutrients and removes wastes. They heal slowly, and the matrix has the chondrocytin sulfate, and that contains collagen fibers. You'll be able to see that. And the types of cartilage vary with the fiber types that are found in each one. So we'll have 3 types: hyaline cartilage, fibrocartilage, and elastic cartilage. Hyaline is first. I think it's the easiest to identify. They, again, look like little bubbles to me. So the matrix is all of that purple. It looks like a liquid. And then the lacuna is the little bubbles that kind of look a lightish blue. And then inside each lacuna is the chondrocyte. This sample has been taken from the trachea. We find it there, also in the larynx, and especially in the fetal skeleton. This helps to ease joint movement, and in the trachea it holds the airway open. Elastic cartilage looks similar to hyaline. I'm going to say normally, I don't want to say always, but normally these lacuna look larger in elastic cartilage than in hyaline, but similar, where the lacuna looks like a bubble, and then inside is the chondrocyte. In the elastic cartilage, you may be able to see the fibers a little bit better than you could in the hyaline, and so those lines, wispy lines going through, those are the elastic fibers. We see this in the external ear and in the epiglottis. And the last type is fibrocartilage. It has large, coarse bundles of collagen fibers, but maybe on your slide it might not look like fibers. It might struggle to see the individual fibers because they are in a clump, but the chondrocytes are there. It's just that the lacuna is not as obvious as in the hyaline and elastic fibers, or cartilage, excuse me. It resists compression and absorbs shock. We see this in the pelvis and in between our vertebrae. Bone is a type of connective tissue. Again, it doesn't feel like it fits in this category, but it's there. So bone does have 2 meanings: an organ of the body, so that would be your femur, the bones that you're thinking of, mandible, and they are technically composed of more than one tissue type. But bone is also a tissue, and so its technical name is osseous tissue, and it does make up most of the mass of the bone. But the bones that you're thinking of do have more tissue types other than just bone, the tissue. So there's 2 forms of osseous tissue: spongy and compact. And you'll be able to see this when you get to bones very clearly. May or may not be able to see it on the slide, but we'll see in the lab. But spongy bone is spongy in appearance. It has lots of kind of extra openings. If you kind of think about Swiss cheese, it does have little, this says delicate struts. I don't know if that's a weird phrase. It has little lines of bone, but then there's kind of this empty space around it. It is covered by compact bone. So the compact bone is more of a protection, and it is denser, and it doesn't have any visible spaces. The spongy bone is found in the heads of the long bones. Now, we're not to bones yet, but think about your femur. The ends would be the heads. and then in the middle of flat bones like your sternum, but it's always surrounded by compact bone. And the compact bone is everywhere else in every bone that you can think of. The cells and matrix surround a vertically oriented blood vessel in long bones. When you look at the bone tissue, it's going to kind of look like, I think about it like a dartboard. It's going to look like rings, concentric rings, and they are surrounding blood vessels. Okay, so here's a look at osseous tissue, compact bone. That's what you'll be looking at under the microscope. And so there's lots in there, lots going on. So one big bracket that you can see, it says osteon. That's considered to be one central canal, and then it's surrounding lamellae. So all of those rings around it, kind of one section of that is called an osteon. And these compact bones are arranged in those osteons that surround the central canal. Sometimes the central canal is also called the Haversian canal. And they run longitudinally along the shafts of long bones. So if you're talking about a long bone, it runs longitudinally, the long way. And in that central canal is where we find the blood vessels and the nerves. Okay, and then there is, the matrix is deposited in these concentric circles called lamellae. Osteocytes are the mature bone cells that are inside the lacunae. These have lacunae too, just like in the cartilage. And they're kind of hard to see on this picture. You'll be able to see them better in the lab. But they are those darker, smaller dots surrounding that central canal. The canaliculi are delicate canals that radiate from each lacuna to the neighbors and allows the osteocytes to be able to contact each other. And then the whole bone is covered in periosteum, a tough fibrous connective tissue that covers the whole entire bone. You'll be able to see that when we get to the gross anatomy, not the microanatomy. Okay, here's a closer look. This got lots of layers, so you want to think of it from the inside out. The central canal is in the very middle. That's the biggest black blob that you see. And then those onion-like layers, those thin circles surrounding, I kind of think about it like a cross-section of a tree as well. Those together create an osteon. That's why it's got that bracket around it. And then the lacuna is the kind of, I don't want to say bubble. This says lakes. That's so weird. It is the space that holds the osteocyte, and then the canaliculi are those canals. And then the whole bone is covered in periosteum. I feel like this is our last type of tissue. I'm not sure. The blood is a fluid connective tissue. Its function is to transport cells and dissolve matter from place to place. The blood has a liquid ground substance, which is called the plasma. And then the cells and cell fragments are called formed elements. But really they're just cells and cell fragments. So the two types of cells that you know already are red blood cells and white blood cells. And then platelets are technically cell fragments, and they are involved in clotting. And you can see on the picture the platelets. When you look at the blood, you may or may not see the platelets. They're very tiny. They should be stained purple as well, but they are much, much smaller than the white blood cells that are stained purple. It is weird that the white blood cells will be purple on your slide, but that's so that you can be able to see them. When you're looking at that slide in the lab, I would encourage you to move it around so that you can see all the different types of white blood cells.